Hey there, I'm Mina.
And I'm Daryl.
In this video series, we're going to take a closer look at the world.
Way closer.
We're going to uncover the hidden chemical changes that are responsible for the structure and functions of all living systems and support how we live. To understand them, we have to look deep inside.
From the macroscopic to the microscopic to the molecular and even the atomic scale. Today we're taking a close look at how carbon is transformed during everyday events.
Food, fuel, plants and animals, whether they're alive or dead, all contain carbon atoms and store or use energy.
We're going to do an investigation and look a little closer to examine what's happening on a very, very tiny scale.
Right, and today we're feeding mealworms.
Okay, Nina, this investigation is about mealworms. We'll have a worm's eye view of these guys chowing down.
We're going to have some happy mealworms because they're gonna get served dinner. Yummy!
When an animal like a mealworm eats something, we can see on the macro scale that it chews the food up and swallows it. But what exactly is happening that's too small for our eyes to see? How are mealworms changing matter and energy when they eat, grow, and move?
What's happening at the molecular level with atoms and molecules?
We want to understand what's happening chemically when mealworms eat and grow. To do that, we ask 3 questions.
The movement question.
Where are atoms moving?
The carbon question.
What is happening to the carbon atoms?
And the energy question.
What changes in energy are taking place?
We can learn more by weighing mealworms and their food before and after they feast. BTB is bromothymol blue. BTB changes its color when carbon dioxide is added, like when you blow bubbles into it. We can use BTB to see if carbon dioxide concentrations increase in the air when the mealworms are eating. So let's make some predictions. What gains mass? What loses mass?
And don't forget carbon. What is happening to the materials with carbon atoms?
Is energy involved here? Where would it be coming from? How would it be changing? What do you think will happen? Be sure to explain your predictions as we pause the video. Okay, let's start our investigation and see if your predictions were right.
Before mealtime for the mealworms, make sure you've got your scale, your potato, your BTB, and the stars of this investigation.
The mealworms. We start by weighing our worms.
We have the weight of the worms on our shoulders.
What?
Weight of the world? Never mind. We'll want to weigh all the worms and also the potato to fully understand the mass change. Well-balanced mealworms.
Here's a sample chart from another classroom with starting mass data. Our potato started out at 12.5 grams, and the mealworm started at 15.4 grams. And we're putting in our dish of BTB to detect any changes in the concentration of CO2. Our starting color is blue, and we'll need to mark that on our data chart.
These little guys will grow up to be beetles someday. They need to chow down and put on some pounds.
Maybe not quite pounds, but we'll see. Now, it takes about a day to feed the mealworms, so we'll speed this up.
Wow, they're hungry.
Eat up, everybody.
Okay, time to weigh everything now that the feasting has ended. And here are our mass changes. We started with 15.4 grams of mealworms, and now we're up to 15.9 grams. That's a gain of 0.5 grams. And the potato went down from 12.5 to 11.3 grams. That's a loss of 1.2 grams. And our data are right in line with the data from another classroom. These are our data, but you have data too. How do your results compare with those on the chart? Is there a pattern? Pause the video and discuss. So, looking at the data, it looks like all the mealworms gained mass, but not as much mass as the potatoes lost.
If the mealworms gained mass, that means that atoms moved into them. But something else is going on too. The mealworms didn't gain as much mass as the potatoes lost.
So where did that extra mass go? Could the mealworms be losing mass at the same time as they're gaining it?
The BTB should provide a clue. We had a color change.
The BTB turned yellow, indicating that carbon dioxide is going into the air.
Where did the carbon dioxide come from? One more thing. It looks like the mealworms are moving around a lot. Where did they get all this energy?
Lots of things to review. And some unanswered questions. There were definitely atoms moving. The potato lost mass. The mealworms gained mass, but not all the mass. Where did the missing mass go?
The CO2 concentration increased. So where did carbon atoms in the carbon dioxide come from? And finally, the mealworms are getting energy to move around from somewhere. How are the mealworms getting energy? What are the mealworms doing with that potato after they eat it?
And look at those full bellies. They're lucky they wormed their way into this one.
Good luck in your investigations.